Welcome to Homework Lib.
Over here we wish to prepare a buffer at pH equal to 4, employing a combination of sodium benzoate and benzoic acid, which corresponds to a pKa equal to 4.2, and we're told that the concentration of benzoic acid solution is going to be equal to 0.1 molar, and of the benzoate, sodium benzoate, we're going to have a concentration of 0.22 molar. And the total volume of my solution needs to be equal to 0.1 liters, which is 100 milliliters. So, with this information, we are going to find the volume of each of the compounds that we need to add. So, of benzoic acid and of sodium benzoate. I'm going to abbreviate each of them as HB and as B minus, just to make the notation a little bit simpler for us. So, in this case, what is going to happen is that we can find the pH for a buffer solution according to the Henderson-Hasselbalch equation, which tells us that pH is equal to pKa plus the logarithm of the concentration of the conjugate base, in this case is going to be the benzoate anion, divided by the concentration of the weak acid, which is going to be benzoic acid. Replacing the values that we desire, we have 4 and 4.2. And instead of having the concentrations, what we can say is that the concentration on the final solution is going to be equal to, in the case of benzoate, we're going to have the total amount of volume that we require multiplied by the volume of benzoate that we have added times the concentration of benzoate of the solution. In this case, 0.22 molar. In the case for HB, what we can say is the same, but with the concentration of my benzoic acid, which is 0.1 molar, multiplied by the volume of benzoic acid divided by the total volume that we have. Other information that we can provide is that total volume is going to be equal to the volume of benzoate that I added plus the volume of benzoic acid that I had. Replacing these concentrations into our logarithm, we're going to see that volume of B minus times 0.22. Well, let me put it first 0.22 to make it a little bit more pretty in terms of the explanation. 0.22 molar times the volume of B minus. Notice that this amount is simply the amount of mole of benzoate that we're going to have, divided by 0.1 molar times the volume of HB. Perfect. So now we can isolate for getting this equation. On the left-hand side, we're going to have 4 minus 4.2, which is minus 0.2, is equal to this logarithm. And to get rid of the logarithm, we can exponentiate employing these bases. 10 to the minus 0.2 is going to be equal to 10 to the logarithm. That is what is inside the logarithm. In this case, we're going to get 0.22 divided by 0.1 molar. The molarities are going to cancel out, so we can get rid of them already, if you want. And this is going to multiply the volumes of benzoate and of BHB, of benzoic acid. So from this equation, we're going to get that volume of HB is equal to volume of B minus, and the factor that we're going to take into account is going to be 10 to the minus 0.2 divided by 2.2. The other equation that we can employ is that volume of B minus plus volume of HB is going to be equal to 100. So what we're going to do is replace the value for B minus over here into our second equation and solve for volume of HB. So the second equation is going to become volume of B minus plus, we're going to replace the volume of B minus So we're going to get 10 to the minus 0.2 divided by 2.2 times volume of benzoic acid plus volume of benzoic acid is equal to 100 milliliters or 0.1 liters. We're going to factorize volume of HB. This becomes 1 plus 10 to the minus 0.2 divided by 2.2 is going to be equal to 0.1 liters. And finally, the volume of HB is going to be equal to 0.1 liters divided by this factor of 1 plus 10 to the minus 0.2 divided by 2.2. This is going to give us 0.0777 liters, which is equal to 77.7 milliliters. Now, to solve for the volume of B minus, we can employ either equation. For example, from here we get that volume of B minus is equal to 100 milliliters minus the volume of HB, or we can apply the equation over here. Regardless of the method that you employ, the result is going to be equal to 22.3 milliliters. So we're going to require of the volume of benzoic acid with concentration of 1 molar is going to be equal to 77.7 milliliters, and the volume of benzoate with concentration of 0.1 molar with concentration of 0.22 molar is going to be equal to 22.3 milliliters. So this is going to be our final answer. It would be all, and thank you very much and have a good one.